Good morning, everyone. SA Engineering College is a renowned institution with a legacy of 26 years of excellence in education. It is an autonomous institution affiliated with Anna University, a prestigious technical university in India. The college has earned accreditation from NAC, National Assessment and Accreditation Council, and NBA, highlighting its commitment to qualify education and continuous improvement. SA Engineering College offers a diverse range of programs, including 11 undergraduate courses and 6 postgraduate courses. The institution is known for its academic rigor, innovative teaching methodologies, and emphasis on holistic development. It gives me great pleasure to welcome you all to the Tech Series event 4.28, where we dwell into the fascinating world of machine learning tools and techniques. Today, we have the honor of hosting a distinguished speaker who brings a wealth of knowledge and experience in the field of AI and machine learning. Abhishek sir, Abhishek sir is currently a senior associate in learning at Infosys, specializing in AI, machine learning, and data science. With over 2 years of extensive experience, he has significantly contributed to the development and implementation of cutting edge AI and ML solutions. His expertise spans across generative AI, large language models, blockchain, Python, and various packs of data science, including data analysis and visualization. Throughout his career, Abhishek sir has been instrumental in driving innovation projects and training initiatives. His journey at Infosys has seen him excel in various roles, from system engineer to his current position as senior associate learning. His contributions have been particularly impactful in remote working environments where his skills in communication and deep work have shined brightly. Today, Abhishek sir will share his insights on the latest tools and techniques in machine learning, shedding light on how these advancements are transforming industries and shaping the future. His extensive background and hands on experience make him the perfect speaker for this session, and I am confident that we will all gain valuable knowledge and inspiration from his talk. Without further delay, please join me in welcoming Abhishek sir to take over the session. Please, sir.
Yes, yeah. So thank you, ma'am. So hello everyone, good morning. So am I audible to you all?
Yes, sir, you're audible.
Thank you. Thanks for your confirmation. Okay. So first of all, welcome to this session on AI and ML. We are going to see about machine learning tools and techniques. So it's going to be very a generic session, in this case, and just a basic intro sessions, right? Okay. So we don't have so much time. So I'll just directly go into the session. Okay. So I'll be expecting some queries as well as some answers from your side as well. So I'll just share my screen. You just let me know whether my screen is visible or not. My screen is up. Can anyone just let me know whether my screen is visible or not?
Yes, sir, your screen is visible.
Okay. And my voice is also clear, right?
Yes, sir.
Oh, thanks for the confirmation. Okay. So let's go with the table of contents. So what are the topics that we are going to see today? So first we'll talk about what is AI and what are the examples of AI, right? So without knowing that it is an AI or not, we are dealing it daily, we are using it daily, right? So let's talk about the examples as well. and we will talk about what is ML. So what is the difference between AI and ML? So what is ML and what are the types of ML? So ML in this case, that is machine learning. Machine learning and what are the types of machine learning and what is a machine learning process? What is a machine learning process, right? Then, if time permits, we will just briefly see about what are the different types of machine learning and some examples of this machine learning. Uh, then generative AI, if possible, just an overview. Or we can have what are the tools and platform that you can perform this machine learning and AI. Okay. So first, let's talk about AI. So what is an AI? Like, what are the examples of AI? So what is an AI? Okay. Anything which is doing without any human intervention is called an AI, right? So something is happening without any human intervention. So we call that as an automation or we call that as an AI. Okay. So let's talk about some example. So if you talk about Netflix, then Google, or we can take Amazon or Spotify. Spotify or the most current trending, which is called OpenAI. Okay. Okay, as I have already mentioned, I'm just expecting some answers from yours here as well, right? So what is a common thing from this applications? So what are the common things? Okay. So that is AI, right? AI is a common thing. Okay, let's talk about Netflix. So whether AI is present in this Netflix or not. Yes, it is there. When then what about this Google that you are using daily? So is there is any AI which is present in this Google or like the Google applications that you are using, like Gmail, Google Photos, everything. So whether AI application is present in this or not, yes, it is there. Then what about Amazon? Just a e-commerce website, right? Amazon, Flipkart, whether there is any AI application is present in these websites or not. Yes, it is there. So let's talk about Netflix first. So what is an AI application which is present in there? So have you seen this recommendation? That is a movie recommendation, right? So what it is doing, it is trying to fetch your interest from the movie that you have already watched. That is from your search history, right? Which you have already watched. Okay, this person is very much likable. Okay, assume you are a person who is very much likable for scientific fiction films, right? So you usually watch those kinds of films or action films, right? So the next time when you are going to the Netflix again, so what it will do, it will give some suggestions, that is a recommendation related to those genres alone. So this is how it is happening because of this AI, right? Then in Google, so what is happening in Google? Let's take Google. Let's talk about Gmail. So what is an AI application which is present in this Gmail? Any idea? What is an AI application? Or photos? Google Photos. Is there is any AI application which is present in those two applications? Yes, it is there. Any idea about what is an AI application and what is the exact use of these applications? So are you using it daily? Yes, you are using it in your routine, like a regular life, right? So what is an AI application which is present over here? Okay. So in Gmail, have you heard about spam detection? Spam detection. Okay. So assume you are getting a mail. If the mail is a spam mail, right, which is not so much useful for you, so it is automatically going into your spam folder. You are not doing anything, right? So there is no human in between sitting in between you and the and your Gmail and classifying, okay, this is a spam mail. So it should go to the spam folder. Okay, this is a good mail. It might be useful for him or her. Yes. So let it go to a normal folder. So there is no human sitting in between, right? It is doing it automatically. So how it is doing? So this is an AI application. So it has already got trained by millions of Gmails and it got to know, okay, which mail is a spam and which is not a spam. And in Google Photos, so how it is helpful? Whether there is any AI application, like what is the exact use of this Google Photos? Hope you have already seen this Google Photos, right? Okay, so what is the use of this Google Photos? Like, what is the use of that particular AI in this Google Photos? That is classification. So in the case of Gmail, it is spam detection. It is spam detection. Then in the case of photos, it is classification, right? So just go to your Gmails and just go to your Google Photos and just have a check. So you can able to see whether if there is a group photo, you can able to see like you can able to fetch each and every individual photos, right? So how it is able to classify those photos, like according to the location, according to the faces of a human, whether it is a human, like not only a human, it can also able to classify between living and non-living things, right? So you are not doing anything, but how it is happening? Because of this AI. Okay. Then what about this Amazon, Spotify, like Netflix, Spotify also same recommendation, song recommendation in this case. Then what about which one? Yeah, Amazon. So what is an exact use of this AI application in this Amazon? Here also the same thing, recommendation of your product, recommendations. So assume you are buying iPhone over here. So what it will do? It's going to recommend you a product which is related to the phones, like we can say temper glasses, then back cases, which is related to the phone, which you have already bought, right? So this is an AA application. So what is an AA? Anything which can able to do its own task. So anything which can able to do its own task without any human intervention. This is important. The example that we have already seen, right? There is no human intervention between this recommendation, this spam detection, classification, right? Yes. And there are so many applications like Tesla. What is this Tesla? A driverless car, right? Driverless car. I've heard about the word Amazon Go, which is located in Seattle. So it is a retail shop. There is no human in this retail shop. So if you want to know more about this Amazon Go, you can just uh, so Amazon Go. Here it is. I'll just give you this link. You can just look into this, right? Okay, I'll just share this link. Okay, so we can just go and type Amazon Go in this YouTube. You will get to know like introduction to Amazon Go. So world's most advanced shopping technology. So which is only possible by AI and ML, right? You can just look into this. Okay. So likewise, there are so many examples of this AI. Okay. So now we have got to know what is an AI. So what are the examples of AI? But how it is possible? So how they are performing this AI, right? So there are so many techniques. So as of now, we are going to see about one of the techniques that is ML, which is nothing but the machine learning. So what is this machine learning? What is the relationship between AI and ML? So can you able to perform AI without ML? Like those questions you can able to answer. So once we are done with this session. Okay. So first we will see about ML. So what is machine learning? as the name suggests, learning. So what is going to learn? Machine is going to learn. So how it is going to learn? So with the help of us, it's going to learn, right? Okay. So what is a technique? So how it is exactly learning? Okay. So according to a pioneer, like who is of a data scientist, so his name is Arthur Samuel. So what he is mentioning is, so it is a field of study that gives computers the ability to learn without being explicitly programmed. It's a field of study that gives computers the ability to learn without being explicitly programmed. So what is mean by without being explicitly programmed? Okay. So assume in a general programming. Okay. So let's talk about general program. So in a general programming, what you will do, assume you will give some input data like A is equal to 5 and B is equal to 5, right? We will give some set of instructions or rules or rules. Like what exactly should happen in between this, right? So I want C is equal to A plus B, something like this, right? So what the computer will give, it will give you the output. So what is the output here? C is equal to 10, right? So this is what a general programming happens. This is how it has happened, general programming, right? So now let's talk about explicitly programming. Explicitly programming. So what is here in this explicitly programming? So the same thing, we'll give some input data. Let's take A is equal to 3, B is equal to 3, right? And we will give the output type, something like this. So what does the machine will try to do in this case is it will try to find out the set of instructions. That is how it is happening. Okay, C is equal to A into B. So this is a set of instructions. Okay, let me just give you some real world example. Assume you are going into the ATM for this general program, right? You are going to the ATM. So once you are inserted your ATM card, so it will ask for a language, right? Okay. So what is happening here? If the amount which is entered by you, so amount entered by you, right? Which is less than bank balance, right? It's going to give you a money, right? So that is another one case, right? If the amount entered by you is greater than your bank balance. So what it's going to give you? Insufficient balance. Some message it is giving, right? So which is already predefined. So we have already given some set of rules to those machines. So by those rules, it is giving you these kinds of messages like, right? So this is what a general program. But in the case of explicitly programming, you are going to give some input data and you are going to give the output data. So here in this case, input data is this one and output data is this one. So it's going to give you the set of rules or instructions. So this is called a machine learning. So what is a machine learning? Without being explicitly programmed. So the computer is going to learn. So let me just give you some more examples so that you will understand more. So assume I'm having a data like this, X. So 1, 1, 2, 3, 9. So assume this is the data that you are having. You are having X and Y. So assume this is your input data. X is all your input data and Y is all your output data. So the input of X is equal to 1 is 1. The input of X is equal to 2 is 4. The input of X is equal to 9 is 81. Something like this you are having, right? Okay. Now, if I ask you, if I give you the value of X is equal to 12, so what is the output of this X? So what will be the output of this X is equal to 12? Absolutely, it's going to be 1 double 4, right? So how? It's able to find out the pattern, right? So what is the pattern over here? Y is equal to, can you say like this, Y is equal to X square. So this is a pattern of this particular data. I hope you all agree with this point, right? Now, whatever may be the value of X, it may be 20, 30, 100, you can able to find out the value for that particular input. That is, you can able to find out the value for Y, right? So how it is possible? By using this particular set of instructions or rules. Now, the computer will be having the ability to learn this set of rules or instructions. This is what we are not going to these, we are not going to explicitly mention this rule. Y is equal to X square should be applied to this particular data. We are not going to give. That is what. So what is an ML? So without being explicitly programmed, computers the ability to learn without being explicitly programmed. Here we are giving some rules and set of instruction. We are giving something to the machine. But in this case, it's going to learn these rules. It's going to learn this set of instruction. So we are not going to mention anything explicitly to the machine. So this is what a machine learning, right? Okay. So if I have to say this, so okay. So let's talk about some real world example. So okay. So assume you are standing over here, right? Okay. So assume you are standing over here and this is your destination. Okay. This is your destination. This is you, and this is your destination, right? So you are having three different ways. One, two, three different ways to reach your destination. Okay. So what you will do? So here it is, we can take this as 30 kilometer, and here it is 50 kilometer, and here it is 60 kilometer. So which way you will choose? So this is okay. C, D, E. Let's take. Okay. So you are having three different ways to reach your destination B. Okay. So this is of 50 kilometer, this is of 30 kilometer, and this is of 60 kilometer. Right. So which way you will choose? Absolutely, you are going to choose the option D, right? The path D. But how did you get to know? So there are some chances, right? So by the data that you have already got, right? So that is called our input data. Oh, we can say this is input data. Input data are historical data, right? So what you are going to do? You are going to get some insights from your input data or the historical data, right? Okay. So what you are going to perform? You are going to learn something. You are going to learn from this input data or this historical data, right? So based upon this, you are going to perform. So how did you get this input data? So in this case, so from your parents, so from your friends, so from the government boards, like there will be some boards, right? So in the highways, okay, this is of 30 kilometer, 60 kilometers. So based upon some historical data, you are getting some insights. So based upon that, you are learning, okay, this is a very shortest distance. So I have to choose this one so that I can save energy, right? You will choose those way, right? So that you are performing. So this is what machine learning is actually doing. So with the help of our input as well as our output data, okay, so it is going to learn something. That is, it is going to find out the pattern. So this is very much important. So what it is actually doing, it is find out the pattern. That is our rules. Machine is finding the pattern. Our main goal in the case of a machine learning. So once we find out the pattern, we are going to execute with the help of our pattern that we have already found. That's it. This is what a machine learning. Okay. So this is what a machine learning, right? Okay. So as of now, we have seen what is an AI and some examples and what is ML and some basic example, like a basic example in this case, how it is actually performing, right? This is a principle of ML. So we are going to give some data. With the help of data, it's going to find out the pattern or reads. So with the rules, it is going to perform, right? Exactly. So this is what an ML. Okay. So what is AI here? Like how AI is okay. So how can we relate AI and ML in this case? So in this case, if you see here, with the use of input and output data, we are learning something, right? That is, we are finding out the pattern over here. So this is nothing but a machine learning. This is nothing but the machine learning. So this is what a machine learning. Then what is AI? Which is nothing but from here to here. This is called artificial intelligence. So this is what a artificial intelligence, right? Okay, now let's talk about in this case. So how it is related? So let's take this okay, spam detection, right? So the machine will already got trained with millions of mails. So with those mails, so the human will be having some instructions like with those things. So we will give something, right? Okay, if the mail is having something like the word called a business or virus, something like which is not very much useful, right? Those words, some like abusive words, or like anything we can take. Okay, so we will give something. Okay, if the mails is having these words, you have to put it in the spam. Otherwise, you can put it in the general folder. right? So we will already train these models with the use of these mails, right? So that you can be able to classify your mail whether it is spam or not spam, right? So this is what actually happened. In the recommendation as well, the same thing. It will already got trained with millions of data. That's why if you are watching a same kind of genre movie, so when you are going into those application next time, it's going to recommend you the same genre movie. Okay, this person is very much likable to the action movies. Simple. It's for the customers, right? They won't allow the customers to leave from their applications, right? So if they did, they will go into the loss. That's why, right? So assume you are a person who is very much likable for action kind of movies. So what happens if it recommend you always the anything like scientific movies or a comedy movie? You want to use that application, right? So it should recommend you the movie which you are very much likable, right? So how it is possible with the use of this AI application, right? Okay, I hope you got some thing what is machine learning and how it is actually happening, right? Okay. Now let's talk about a machine learning process. Then we'll talk about what are the types of ML. So machine learning process. Okay. So what is this machine learning process? So assume you are having your historical data. Let's take in this case, this is a historical data. Okay. So this is a historical data. So the first process is to get your historical data. That is input for your data. Or we can say the past data, which has already done. Right. So assume in this case, we are already having our historical data. This is our past data. Right. So we will do some feature engineering technique. So the second one is feature engineering. So what is this feature engineering? As the name suggests, feature. We are going to engineer those features. Features are nothing but this is your features. Okay. So what is this feature engineering in this case? Okay, in the real world, you will be having a lots and lots of data, right? So you can't tell you will get only the pure and clean data. It's not the case, right? So there is a high chance you will always get the, like not always, there is high chance you will get the like impure data, right? So assume in this case, you got something like this. You don't have Y for this and this. You're getting a nil value, assume, right? What is this feature engineering? Is you will treat with this data. That is, you will try to clean up this data. So cleaning up data. Feature selection is also there. So cleaning up the data is in this case. So assume you are not having any values in this case. If the machine try to understand the pattern in this particular data, right? So the result, the pattern, it won't be having that much accuracy. There will be some mislead. Absolutely right. Because you are having some null values over here. There is a high chance the machine can learn wrongly. So assume you are having more null values. So nil, something like this. See now, is that possible to learn machine correctly? No, right? There is not high possibility. So we will try to clean up this data, right? That is cleaning up the data. Okay. So this is a feature engineering technique. And another one is okay, feature selection. So what is this feature selection? So let me just give you an example. Okay, I hope you all are aware of like cricket, right? Okay. So in cricket, so assume we are going to check whether the batsman is going to hit a six or. So how can we find out whether the batsman is going to hit a six or not? So what are the features which is very much important for this? So we are going to predict whether the batsman is going to hit a six or not. Okay, though you are already aware of this thing. So what are the features? So we need bowler name. Who is the bowler? Whether he is a perfect bowler or not. Whether he is a dead over specialist or not. Right? Right? So bowler name is very much important. The batsman name. Whether he is a perfect batsman or not. Whether he is a finisher or not. Right? So this is also very much important. Then pitch condition. Is the pitch condition is important? Yes. What about the humidity? Whether the pitch is dry or not? Right? Yes. Pitch condition is also very much important. What's the type of ball? Whether it is a red ball or a pink ball or a white ball. Is that important? Yes. This is important, right? This is also important, right? So if it is a red ball or a pink ball, so there is some difficulty, right, in hitting a six because of its spin. So this is also very much important in it, right? Okay. Then we can take what is the umpire name? Then how much crowd? Now you just let me know to find the answer for this question, whether the batsman is going to hit a six or not, whether this umpire name and how much the crowd, how much people are present in this crowd. Is it very much important? Is it reflecting to find the answer for this? Is it not influencing anything in this case? Right? Yes, this is what feature selection. That is, we are going to select the particular feature which is very much important to give answer for our question. So in this case, this umpire name and how much the crowd is, this is not very much important feature. So what we will do in this feature engineering technique, we will remove these features, removing unwanted features. This is what a feature engineer, right? So every time you won't get a correct and clean data, right? You will always get some impure data. So you have to go up with this data, right? Okay. So this is called feature engineering. Okay. So in this case, assume you are you have cleaned up this data. This is our historical data. So after our feature engineering technique, we got the clean data like this. Just a plain data set, right? Okay. So you got a clean data. So now what you will do is you will split this data. This is your third process. So what does mean by splitting the data? Splitting is nothing but separate, right? So you will split into train and test data. So the first one is going to be the train data. The second one is going to be the test data, right? So what is the purpose of this training as well as the testing? I'll let you know. So basically, we'll split into this is a like a mathematical thing. Like by it's going to be 80 to 20%. It's not always it is not as always 80 to 20. So it's based upon the size of a data which you are already having, right? But in general, they will split into 80 is to 20 ratio. Not like this. We can put like this 80 is to 20 ratio. So the most of the data should go for a train, and the less number of data should go for a test. It is in the form of ratio. Okay? Training and test, right? Okay. Now let's take. So randomly we'll take two things. So this one is in our testing data. Now this is in our training data. Okay. So now you can see we are having some data for training and some data for testing. So what is the main purpose of this? What is the main purpose of this training and testing data? So now you will got to know that. So you are having some data for training, okay, and some data for the testing. This is our third process. So what you will do is you will use some machine learning algorithm, okay, to build a model with the use of this training data alone. You are not going to touch anything from the test data. You are going to use this training data and you will build the machine learning model. Okay. So assume you have built a machine learning model. This is our machine learning algorithm that you have already built. Okay. With any of the algorithm, we'll go with the like what are the different types of machine learning. I'll let you know. So before that, so we have built a machine learning model, right? So what you will do is you will give the input data. We'll give the input data. So this is our input data, right? Now you can see with the use of this input data, you have built the machine learning model, right? Now it find out the pattern. So in this case, what is the pattern? So this is in this case, our pattern is so y is equal to x square, right? This is our pattern. So you have find out the pattern. But how did you know whether the machine is predicting correct or not? So is there any possibility? How did you know? Is it giving us the correct answer only? How did you know this pattern is correct or not? We have to check with something, right? So that is what our test data. Now what we will do is we will give the test data. So this is our test data, right? Okay. Now what we will do is we will give our test data into the model that we have already built. So it will check. So what it will check is whether y, what is the value of y here? 81. 81 is equal to x square. What is x square here? 9 square or not. Whether, okay, this is 16. Whether 16 is equal to 4 square or not. It will check whether the pattern that it got and whether the test data both are same or not, right? So based upon this, it will give you the accuracy. You can find out the accuracy of the model. Able to find out the accuracy or not. So how can we find? With the use of test data against the train data. So the simple. So I'll just repeat it once again. So what you are going to do is you are going to build the machine learning model with the use of train data alone, right? So once you have built the model, you are going to check the accuracy of your test data. Sorry, you are going to check the accuracy of your data with the use of your test data, right? So with the use of this train and test data, you are going to find out how accurately the model is performed, right? So this is what a machine learning process. So once the validation is done, if the accuracy is like it's not going to be the 100%. I'll tell you, it's not going to be the 100%. So I hope you all know this, right? Okay, today's climate is like today's weather report is there is a 100% chance there will be a rain in Chennai. It's not possible, right? It's not always possible, right? We are not a god to predict 100% correct. It will be always a possibility. Okay, 90% of accuracy. It is having. There is a 90% of a chance. This mail is going to be spam. There is a 90% of a chance. This person might be having a heart disease or not. Right? It will be like that one. Right? Yes. So once the accuracy is done, so once the model validation is done, you can able to deploy this machine learning model. So after deployment, I hope you know, right? So whatever the data, right, it can able to perform. Okay, now we are giving x is equal to 20 to this model, right? It can able to tell y is equal to 400 because it already got the same similar data. So with the use of the similar data, it got already trained, right? Yeah. So this is what a machine learning process. Okay. So what is a machine learning process? Okay. Once we are done with the trained data, we are going to, what we are going to do? We are going to ML, build a machine learning, right? Okay. So once we are done, we are going to validate with the use of the test data. Validate model with test data, right? So once the validation is done, we are going to check out the accuracy, how it is performing, right? So if you are satisfied with your accuracy, you can deploy your machine learning model. So once it got deployed, you can able to predict it with the new data, right? So this is what a machine learning process is. So these things are called machine learning process. So you are going to get some historical data or there's input data or past data. Then you will be doing feature engineering. So once you are done with the feature engineering, you will split the data into 80:20 ratio. That is trained data and test data. With the use of trained data, you are going to build a machine learning model. With the use of test data, you are going to validate your model, which you have already built. So once it is done, you are going to deploy your data and it's going to make a new predictions of the new data, right? So this is what a machine learning process. This is what exactly it is happening. I hope now you will get some idea about how these applications are like it's working, right? In the case of spam mail, I have told you, right? So this is how it is working, right? It got already trained with the millions of data. We have already trained it, right? So how it got trained, it's going to perform. That's what, right? So this is what a machine learning process. Of. Now let's talk about what are the different types of machine learning. So one is supervised, second one is unsupervised, third one is a reinforcement. So what is the supervised machine learning technique? Simple. Assume this is your model. So what is the supervised machine learning technique is? So assume you are having some data like this. The name of is this circle, circle, and this is a square, straight line, and this is a square. So this is a line. Okay. So you are going to build a machine learning model for these images. So this is a line. As in this is a line. Okay. Okay. So you're going to build a machine learning model for these images, right? Now this is called a labeled data. So why it is called labeled data? Because it's having a label. That's it. Simple. So it's having some label in it, right? So what is the label here? Circle is a label. This is called circle. Okay, this is called line. This is called circle. This is called square. If it is present in this shape, this is square. If it is present in this shape, it is called circle. So it can able to learn itself. So this is a label data, right? So I have a build a ML model, right? So you have already picked. Now what you are going to do is you are going to give some new shape to your model. You are going to give the new shape to your model. So what it's going to give you? Okay, if it looks like this, according to the data which I have already got trained, this is named as circle. So this is called supervised machine learning technique. If the data that you are having, which is already labeled, which is called supervised machine learning technique, ML with a labeled data. If you are performing a machine learning with the labeled data, that is called a supervised machine learning technique, right? Then what is this unsupervised machine learning technique? A small change is there. Okay. Now you can see here, we are having something which is not having any labels, right? We are just having some shapes, right? So this is some shapes you are having. You're not having any labels inside it. So we have built a machine learning model with the use of these shapes, right? So now what you are doing, you are giving some new data to the model, right? So what it will do is it will try to find out the similarities between these images, between this pattern. Here, one, two, three. Now what it will give us if you give a new image, a new data to the machine learning model, it will give you this entire thing. It will give you this entire, it will give you this entire data. This is called unsupervised machine learning for unlabeled data. Tell me some example for this unlabeled data now. You can easily put, which is nothing but the recommendation. Assume this is an action kind of movie, scientific fiction movie, okay, comedy genre movie, right? It got already trained. So now if you continuously try to watch action kind of movies, so it's going to recommend you only the action kind of movies, not other type of movies, right? So the product recommendation, so everything, right? It will comes under this unsupervised machine learning technique. In a perfect way, if you want to say is grouping similar entities together and say ML with unlabeled data. What unsupervised machine learning technique. So what are the things that we are seeing? Types of ML techniques, right? So this is called unsupervised machine learning technique. Then the third one is a reinforcement learning, which is going to be very much interest and which is going to be somewhat difficult. What is this reinforcement learning? Okay, so assume you are playing a chess, online chess. So if you are using easy, okay, the level as easy, you can able to win, right? So if you are using intermediate, it's going to be somewhat hard. If you are using hard, it's going to be very, very, very difficult, right? Because the machine got already learned with the use of this reinforcement learning. Or we can say how a human is learning, the same way the reinforcement learning exists. So assume there is a child, okay? So he doesn't know anything, like let us take a 2 age, 2 or 3 age. Okay. So he or she doesn't know anything, right? So assume there is a fire. So the child will absolutely go to touch, like he or she will directly try to touch the fire, right? So once he or she got injury, he's not going to touch the fire. So he got to know, okay, if we go near to this fire, it's absolutely going to injure me, right? It's absolutely going to hurt me. So he or she won't go to the fire, right? So how it is learning? By mistakes. In this case, by feedback, right? By feedback, it's going to learn, right? By, or we can say by rewards. Let's take self-driving cars, penalties. The example of self-driving cars. So as a data scientist, they will give some rewards. Okay. In the case of a red signal, if you stops correctly, 100 points reward, right? So moves in green, 100 points is reward. Slows down, speed breaker, 50 points is reward, right? Okay. Penalties uh, doesn't stops at red. Some points is penalties. Let's take the opposite thing. Okay. If it stops at green, some points is penalties. Something like this. Okay. So we will define some rules in this reinforcement line, right? Okay. So what does the mission will do is it will try to increase this rewards and it will try to minimize this penalties. If it got penalties, it won't do that mistake again. It will try in a different way, right? So in the same example, like in the chess game, okay. So in a chess game, right? So assume here there is a point. So it is having a four chance. So one, two, three, four. And here you are, right? Actually, it should move to right, but if it moves straight, it will give the penalty, minus point, right? So it won't move to the straight. It will, if it tries to move backwards, it will get the penalty. Then it won't move. It won't move the backwards. If it moves right side, it will get the reward. Likewise, in the reinforcement learning, what it will do is it will try to increase the rewards and it will try to minimize the penalties. In this way, the machine is going to learn without any past data. This is very much important. So I have asked you a question in the beginning. So do we always need data for a machine to learn? Absolutely not. In the case of reinforcement learning, there is no data. We are just going to define some rewards and penalties. No data involved in this reinforcement learning, right? Okay. So this is what a reinforcement learning. So there is some other thing called a semi-supervised learning. What is a semi-supervised learning is it will be having labeled as well as unlabeled data. It is a combination of labeled and unlabeled data. It will be having 80% of labeled data and 20% of unlabeled data. Something like this. And there is some other thing called self-supervised. And these driverless cars and Meta. I hope you all are aware of Meta, right? Meta and driverless cars. right? With the use of this self-supervised learning, it is all. Okay. Okay. So let's come to the last one, that is tools and platforms. So how you can learn this machine learning thing? So you should be aware of any one of the programming language. So in this case, it's going to be the Python. So which is having so much of a library so that you can use it very much easily, right? So you should be aware of any one of the programming language. And mathematics is very much important. Actually, I haven't told you much more thing about this machine learning thing, right? There are types of machine learning. So under supervised, there are some types of machine learning. Unsupervised, there are some types. Reinforcement learning, there are some types. It's like a ocean, right? So I don't have that much of time. So, but get to know that mathematics is very much important for this learning, machine learning related stuffs, right? Okay. So do we always need programming language to this machine learning? No, absolutely not. So you can use this nine platform. So what is this nine platform? This is a machine learning platform which you can use like a drag and drop, and you can perform the machine learning. So it's an open source. If you go to here and if you just type nine, see nine open for innovation. So free and open source with all your data analysis, right? So you can make use of this, right? So are we having only locally? Can we can't we perform in a cloud? Yes, it is there. So in AWS SageMaker. So this is the tools and platforms which you can perform this ML and AI. Amazon SageMaker is there, augmented AI is there, augmented AI is there, then Amazon Lex is there. Hope you all are aware of Alexa, right? Alexa is also an AI tool, which is speech to text, sorry, text to speech, anything which can able to recognize your speech, Google Translator, everything. So this Amazon Alexa is nothing but this is the heart of Alexa. Alexa is running the use of this Amazon Lex, which is nothing but build. You can able to build voice and text chatbots with the use of this Amazon Lex. And there is something called AWS and Deep Razor, which you can perform your reinforcement learning models. There are so many things in cloud platform as well as in local platform. These are all open source. Like this nine is an open source. Likewise, there will be so many things will be there, right? And you have to know about PyTorch. These are the frameworks. PyTorch, then TensorFlow, TensorFlow. I hope you have heard about the word TensorFlow, right? Google Pixel, right? Which is using this Tensor, right? Okay. So these are the tools and platforms which is available to learn the AI and ML related things, right? Okay. So I hope you got something like very minimal thing which is related to a minimal introduction which is related to AI and ML, right? I hope it is fine. So any queries you want to ask, you can just let me know. I'll just option. So if you have no queries, we can just wrap up this session. Like, yeah, we can just wrap up. So if you're having any queries, you can just let me know. Like, I'll let your professors as well. Yeah, thank you.
Okay, sir, I will confirm the vote of thanks, sir. As we conclude today's session of Tech Series 4.28, I am honored to deliver the vote of thanks on behalf of the CSC Artificial Intelligence and Machine Learning Department of SA Engineering College. I extend our deepest gratitude to our esteemed guest speaker, Abhishek sir. Your enlightening talk on machine learning tools and techniques has provided with valuable insights to the ever evolving landscape of AI and data science. Your passion and expertise have truly inspired us, and we are grateful for your time and knowledge, sir. I would also like to thank the organizing committee for their meticulous planning and hard work in making this event a success. A heartfelt thank you to all our participants for your active participation and engagement. Lastly, we kindly ask everyone to take a few moments to fill out the feedback form. Your feedback is crucial in helping us improve future events. Upon submission, you will receive your participation certificates. Thank you once again and have a wonderful day ahead.